Hi guys, in this demonstration I am going to illustrate the dynamic memory allocations in C++ by using the operators new and the dynamic memory deallocation using the operator delete. So it's all about the illustration of C++ operators new and delete. And what's the purpose of new? Using new, we can allocate memory during runtime, or we can call it as dynamic memory allocation. And the purpose of delete is used to deallocate. Deallocate memory during runtime itself, or we can say that dynamic memory deallocation. So now I'm going to show you how can we use new for dynamic memory allocation. Normally we declare a variable like this, int x equal 10, but it is not of dynamic memory allocation. So how will you do a dynamic memory allocation for my data 10, and how will you store the data there? For that we have to use like this. The syntax is like this: new and for what type of data. It may be an integer, it may be a character, the type may be integer or character or any other supported data type in C++. For example, I'm going to say that I want a dynamic memory allocation for an integer data, then the type must be integer. If I want it for a character, the type must be character, like that. So here in this I'm going to specify int. And what does it give? It gives some free memory. It gives some memory during the runtime. Or we can say, in a better manner, we can say that it allocates a memory and it returns the address of the first byte. Actually, it allocates 4 byte. This allocate it allocates 4 bytes, and address of the first byte will be returned. Address of the first byte will be returned. So since it gives some address, we can store in a variable called p. Now p is holding the address of some memory. Got it? Because this portion allocates 4 bytes and it returns the address of the first byte, and that first byte address we are storing it in a variable called p. Since p is holding some address, it must be a pointer variable, and since it is holding the address of some memory where we can store some integer, we can say that it must be an integer pointer. So finally we can say that p points to some address, or p points to some area in the memory where we can store some integer. So now we have to say that now we are going to put the value in that allocated memory. Suppose I want to put 10 in that place. So how will you do that? You know how through the pointer we can reach out to that particular place. So we have to say that the value at that address. You can see here P holds the address of some address of some particular area, or we can say that P hold the address P holds that address. Simply let it be like this. P is holding the address. Now we have to say the value in that address. P has the address. So how will you say that the value at address? Asterisk P equal to. That's a P contains address of that allocated area. Now when you say asterisk here, the value at that address is getting an integer value. Now to access that, we can say that cout the value at address. Now when I run the code, we can see that the 10 is coming. The same thing you can try for different types. Here if you type character, then here also the pointer also should be of character type. So what type you are giving in the right hand side, that should be the pointer's type. That you should be very careful. So this is for storing one data. Suppose you want to store multiple data, a group of integers or group of float, then how will you do that? It's very simple. Its syntax is again new. For any dynamic memory allocation, we can start with new. New. What is the type? For example, integer type. If it is an array, give the set of square bracket. And for how many integers? Like this. So what happens? It allocates memory for 5 integers and it returns the address of the first byte. So here how many bytes will be allocated? For each integer 4 bytes. So for 5 integers, 5 into 4, 20 bytes. So from that it takes the address of the first byte and it will be returned. Since it returns the address, we can store it in a pointer variable. Let it be called P2. Then integer asterisk, that is, it shows that P2 can have some address and it is pointing to integer type. So it must be of type int. Hope that you understood now. Now, through the pointer variable, we can store the data in this array. So how will you do that? For that, you should know about the pointer implementation of the array. Suppose I am saying that consider an array like this. Int a5. Now, suppose you want to display the first element, we can type like this, a of 0. There is a pointer implementation in a of 0. That will I am going to type. It is equivalent to cout asterisk a plus the index value. The same thing we are going to apply here. The first element I am going to insert like this, p2 of 0 equal, for example, 20. So what does it mean? The p2 of 0 can be rewritten like this, asterisk of p2 plus 0. So what does it mean? p2 means the base address. See, p2 contains address of the first byte. So that address plus 0, again the address of the first byte for that first integer value. That is, we can say that in the index position 0. It is getting a data 20. So we are going to check it. Does it give any trouble to us? You can see that it works flawlessly. And now I am going to run it. You can see that the 20 is coming. Even though we are accessing based on the index, there is an internal pointer implementation. Now, so I'll give justification more. Suppose you want to access like this, cout p21. For that, I'm going to put some data first. p21 equal, I'm going to 30. Instead of this, even we can write like this. I'm going to comment this line. For p2 of 1, we can write like this, asterisk of p2 plus 1 equal 30. Now I'm going to execute this, and you can see that the 30 is coming. Now I'm going to give the justification. When you say p2 of 0, it means asterisk of p2 plus 0 equal 20. As you know that, what does p2, what is p2? p2 is a pointer and it has the address of the first byte. The moment you say that, and again it is pointed to integer. So when you say that asterisk at p2, here the net result is asterisk at p2. So you are putting the 20 in the first 4 bytes. Next, when you say that p2 plus 1, okay, assume that um, assume that p2 has value, it means the address which p2 has. p2 has a value 100. Now when you say that p2 plus 1, what does it mean? Asterisk of p2 means it has a value 100. Suppose p2, see here I told you that p2 contains some address. Consider the address as 100. Then when you say p2 plus 1, it means 100 plus 1. It means that asterisk of, normally 100 plus 1 means 101. Since it points to integer array, whenever you add 1 with the address, it will be scaled by 4. So the net result is 104 but not 101. Suppose it is referring to a double array. Then when you say that 100 plus 1, instead of 101, you will be getting 108. So based on the type, this portion will be scaled. If it is of character, there is no scaling, 1 only, because the character size is 1. ASCII code for, here we are following the ASCII code. So like this. Hope that you understood. Now, again go back to this first 3 lines. Now here we have a dynamic memory allocation for integer for storing the data 10. So how will you deallocate? We are going to see that. Deallocate memory. So it is storing only one data, right? So for that, its syntax is like this: delete followed by the pointer variable, that is p. It deallocates the memory, or it will free up the memory. But here it is referring to an array. So slight syntax difference. Delete, then followed by set of square bracket, followed by the pointer variable. This is a syntax we have to follow. Don't put this set of square bracket after p2. As you know that C, C++, all these are very highly syntax oriented programming languages. So we cannot change the syntax what they are specified. Okay. So now I'm going to run it. You can see that it is working perfectly without any flaw. So this is the illustration of new and delete. In the next video, I'll illustrate about the destructor, where we'll be dealing with again the delete operator. Hope that all of you understood. Thank you for watching this.